Hi class, welcome back to another episode of Math 1 Distance Learning. So this lesson, this video is actually part 2 of a lesson that we've already started. So you probably just watched part 1, and we are working on identifying slope in word problems and linear equations. So in the first video, we reviewed identifying rate in word problems. And I explained to you in the first video that rate is the same as slope. They're kind of like nicknames for each other. So we looked at word problems in the first video and we identified the rate and we wrote some linear equations and we wrote some word problems. In this video, we're going to be looking more at the actual mathematics. We're going to be looking at the actual linear equations themselves. So let's go ahead and get started. I'm going to flip over to my DocuCam. You should have your notes in front of you, and this is just a continuation. So we're looking at these notes here, identifying the slope in linear equations. And our objective is to identify the slope in a linear equation, both in a word problem as well as a mathematical equation. So we already looked at the word problems. We also looked at some graphs. So we did this in graphs. And then we worked on some word problems that I gave you. And then we also wrote some word problems. So I gave you a linear equation, and then we needed to write a word problem to actually match that. And where we left off is talking about linear equations. Just a quick review. So we talked about a linear equation. So what are they? So equations that contain a rate. So a linear equation contains a rate. It's got an input variable. We call that the independent variable. And it also has an output variable. Usually that's the y variable, and we call that the dependent variable. And then when we graph a linear equation, it forms a straight line, right? So it forms a straight line, and we've got the word line here in linear, okay? So it forms a straight line. Now, where we left off, we said that they come in two forms. One form is called slope-intercept form, and the other form is called standard form. Now, for those of you that are movie watchers or comic book readers, you know that this is a transformer and this is Optimus Prime, right? So Optimus Prime, like all transformers, can be a robot, or they can transform into some type of a car or a truck. Optimus Prime, he transforms into an 18-wheeler. So I want you to think of linear equations as kind of a transformer, right? You remember the little phrase from the cartoon, Transformers, robots in disguise. How does it go? It was Transformers, more than meets the eye, robots in disguise, right? So they come in two forms, okay? So either slope-intercept form, or we can transform it to standard form, or we can go back. So we can go either direction, okay? So they're like transformers. So let's start. So a slope-intercept form, it comes in the format y is equal to mx plus b. Y is equal to mx plus b. So let me give you an example. Here's an example. So y is equal to mx, and then here's our plus b. It happens to be a minus. Okay. Here's another example right here. This is a different example. So we've got y is equal to, here's our m, which is our slope, negative 3 over 2 x, and then plus 5. That's our plus b right there. So your b, even though it says plus b, it could be a minus or it could be a plus. And then that m, it could be a positive or it could be a negative. Now, we can transform. We can go from this format into standard form. I'm going to show you what that would look like. So this is actually the same equation. And we're going to work on transforming it a little bit. That's not the main focus of this lesson, but we will work on that a little bit. So standard form comes like this. We say ax plus by is equal to c. Now, This equation is this equation, just in a different format. Just like Optimus Prime can be a robot or he can be an 18-wheeler truck. It's still Optimus Prime, right? He didn't go away. It's still the same robot, okay? Just in a different format. So this is this just in a disguise. How about this one here? This one right here is this one in disguise, right? Robots in disguise, right? So it's in disguise, but it's really the same linear equation. It's the same linear equation. Okay, now here's a quick note. In standard form, if we look at standard form, the x and the y, the x and the y, the x variable and the y variable, are always hanging out together on the left side of the equal sign. So if you look at these three examples here, here's the x, here's the y, and they're like hanging out. They're pals, they're buddies, they're kicking it together over here on the left side of the equal sign, right? Here's the equal sign right there. Here's the equal sign. Here's the equal sign. And they are on the left side. Once again, x and y are on the left side. X and y are on the left side. Okay, so in standard form, they're always hanging out together on the left side. In slope-intercept form, if you notice, the y is kicking it by himself. He's hanging over here by himself. He's getting a little alone time. The x is over on this side. The x is on this side. So in slope-intercept form, the y is relaxing by himself over here. Okay? All right. So that's the difference between those two. Okay, so now let's look at some equations and let's see if we can find the slope. We're going to be a little detective, right? That's why I've got this little detective floating around, because we want to investigate and identify, the slope. Okay, so, and then here's a little reminder. Here's a question, actually. Where do we always put the slope when writing an equation? Where do we always put the slope when writing an equation? And here's the answer. On the left side of the x. So we covered that already. We covered that in video number 1. The slope always goes on the left side of the x, but this is really important. That is only when it's in slope-intercept form. Only when it's in slope-intercept form. Okay? All right, so we're going to look at some examples, but let me just make sure I clarify that. The slope is in slope-intercept form. So we can find the slope next to the x. So if I come over here, this side is slope-intercept form. So there's our slope. There's our slope. It's next to the x, next to the x. But that's only true when we write it in slope-intercept form, when we write the equation in slope-intercept form. If you've got y by itself, then you can go, oh, okay, there's your slope. There's your slope. But as soon as we put the equation in this format, there is a number next to x, but that's no longer the slope. If you notice over here, the slope is -3/2. It didn't change to 3. That is not the slope. 3 is not your slope. Your slope is right here. That's just called a coefficient. If you look up here in this example here, 20 is not your slope because this is in standard form. We have to transform it. So that's what we're going to practice. We're going to take this and we're going to transform it so that we're in slope-intercept form, and that way we can find our slope. There's our slope and there's our intercept. We haven't learned about intercepts yet. There's our slope, there's our slope, okay? All right, so it only works in slope-intercept form, only works in slope-intercept form, okay? All right, so here we go, practice. Identify the slope in each equation, transform the equation if necessary. Okay, so the first thing I want to ask you in this example here, what format is this equation in? What format is it in? Is it in slope-intercept or is it in standard form? Okay, Well, it's in slope-intercept. We have the y by itself. It's in slope-intercept form. So since the y is by itself, then we can identify that slope. It's that number right next to the x. Okay, so our slope is actually, it's 5, and our slope is really a rise of 5 over a run of 1. Remember, a 5 really has an invisible number underneath it, has an invisible 1. So our slope is 5 over 1 because this is in slope-intercept form. Slope-intercept form. Okay. All right. In fact, I'm going to put that in here. This is in slope intercept form. So if you're in slope-intercept form, then we can figure out what the slope is very easily. Okay. All right. So how about this one here? Right here. Okay. So on this one, I'm trying to throw a curveball at you. So here's a number next to x. So this is a fraction. Plus 50 is equal to y. But what I want you to realize is I just changed where I put things. So I'm going to change it back. I'm going to take this y and I'm going to move him to the front. And then I've got 2 over 3x plus 50. 2 over 3x plus 50. So the question is, what format is this in? Is it in slope-intercept form like this, or is it in standard form? And hopefully you can see that if the y is by itself, here the y is by itself, then we would say that's in slope-intercept form. So we can identify the slope, and our slope is 2 over 3. Okay, and once again, I'm going to label this as slope-intercept form. Slope-intercept form. Okay, all right, we're going to do a few more. I'm going to turn the page here. All right, so if you're in slope-intercept form, it's really easy to find your slope. It's the number right next to the x, right? It's on the left side of the x, the left side of the x. What's on the left side of the x? Right there, 2 over 3. Okay. Okay, now sometimes we are going to actually have to transform the linear equation. Okay, so in order to locate the slope in a linear equation, you must always transform the equation into slope-intercept form. So we've got to put it into this format. Okay, so just like Optimus Prime transforms, well, we need to transform our linear equation. We need to have it in slope-intercept form. Okay, so if I look at this first one, okay, so y is not by himself. If we notice, here's our equal sign, right? This is like our fence. Remember we talk, when we're solving equations, we talk about this being the fence. So there's our fence right there. And this is on the right side of the fence, and this is on the left side of the fence. So right now, 15 is hanging out with y. And we need to get 15 alone. He needs some alone time. So how are we going to do that? We got to get rid of the 15. So we want to subtract 15 from both sides. And that's going to give us, so these cancel, our 15s cancel right there. Those get canceled. And we're going to get 8x minus 15. 8x minus 15 is equal to y. 8x minus 15 is equal to y. And now I'm going to change this. I'm going to relocate this. So I'm going to take this and I'm just going to move it over to this side. And I'm going to take all of that and I'm going to switch it over to the other side. So it looks like that. Now we have transformed So I took this equation and I transformed it into slope-intercept form. Now we have y by himself. He's on the left side. Right, here's our equal sign. He's on the left side. And over here is the rest. And we're looking for the number next to x. And so our slope is 8 over 1 or 8, right? So 8 over 1 or 8. Okay. All right. Let's try the next one. So on this next one here, what format is this in? What format is this in? Okay, so if you remember from just a couple of minutes ago, I just said if x and y are hanging out together, they're hanging out together on the left side. So here's our left side, and they're hanging out together. Then this would be standard form, and that's no good, no bueno, right? We don't want standard form. We need to transform into slope-intercept form. Okay, so what would be the first thing that we want to do to get y by himself? So the first thing we want to do is we want to get rid of this 12x. So we're going to subtract 12x. This cancels right there. That's gone. So now I'm going to have 3y is equal to negative 12x plus 24. Okay. Now I want to get y by himself. So I need to get rid of this 3. So I'm going to divide everything by 3. So these 3's cancel. And then I've got negative 12 divided by 3 and 24 divided by 3. And it's going to turn out to be this, right? These 3's cancel. Y, 12 divided by 3, that makes negative 4. 24 divided by 3 makes 8. And now we've got the equation in slope-intercept form. Y is all by himself. He's over here relaxing. And we can go find the number next to x. So our slope is negative 4 over 1. Or we could just say negative 4. These are the same thing, right? Negative 4 over 1. This is our rise over our run. Or we can write it just like this. Okay? All right. A few more examples. All right. So here we go. Going to this next one. So once again, okay. So now this one's a little tricky. We've got an x here. We've got a y, but then we have x over here. So remember, we want to get y by itself. So the first thing that we want to do is just, here's our y. So we need to get rid of that 3, but we want to get rid of this first. So how do I get rid of a minus 18x? Well, I'm going to add 18x. Okay, so these cancel. But whatever I do on the right side of an equation, I have to do on the left side. Remember, here's our fence. So whatever I do on the right side, I have to do on the left side. So these cancel. And I get 18 plus 6 makes 24x. And now I want to get y by itself. So I'm going to divide by 3. So these cancel. And I'm going to get 24 divided by 3 is equal to 8. So I have 8x is equal to y. And now I'm going to just swap spots. I'm going to switch the spots. So I'm going to switch this. Let's do it this way here. So I'm going to switch this so that the y is over here equals 8x. And now y is by himself. We don't have any starting amount. That's okay. We're just looking for our slope. And our slope is 8. So 8 or 8 over 1. Okay, so y is equal to 8x. Our slope is the number next to the x. Number next to the x. We always put our rate or our slope next to the x. Okay, here we go. Last two, I believe. Okay, so I'm going to come over here to this one here. And we've got 5x equals a minus 21 and a plus 3y. Once again, we want to transform this so that y is by itself. So right now, the first thing we want to get rid of is the minus 21. So we're going to add 21 to both sides. So that cancels. So over here, I'm going to get 5x plus 21. It's going to look like that. And now I want 3 by its, I'm sorry, I want the y by itself. So I want to get rid of my 3, y by itself. So I'm going to divide everything by 3. And that cancels. Now, I put this problem in here specifically because this isn't going to, they don't want to play nicely. So remember, if he doesn't want to go into that 5 nicely, then we just leave him alone. So it's going to stay 5 over 3. And then 21 divided by 3, that works nice. And so that comes out to 7. And now I'm going to rearrange the furniture. I'm going to rearrange. So I'm going to put my y. It's over here on the right side. I want to put it on the left side. And when I do that, I'm going to get y is equal to 5 over 3x plus 7. So I just took all of this and moved it over here. Y is equal to 5 over 3x plus 7. And then what's our slope? It's the value next to x. So our slope is 5 over 3. That's a rise over a run, 5 over 3. Okay. All right, one last problem. We'll do this together. It's a word problem, so we're going to go back to a word problem. It says you want to buy a new surround sound system for your bedroom. You have $50 already saved, and your parents will pay you $15 a week for doing house chores. Okay, so we want to write a function. I'm going to write an equation here. Okay, so the first thing, so it says write an equation that could be used to calculate how long it will take you to save, and then we know how much we want to save, $365 for the system. So we're going to write an equation based on this information. Okay. All right. So my first question is, what is the rate? Do we have a rate in this problem? What's our rate? All right. Think about it for a second. And hopefully you identified that the rate is right here, $15 per week. $15 per week. Okay. Now, do we have an upfront amount or a starting amount? Do we have a certain amount that we've already saved? Yes, we do. We've got $50. That's our starting amount. Okay, so $50 starting amount. So when we write our, there's our, oops, I kind of goofed up, sorry. So our rate is, this is how we'd write it as a word problem, but when we graph it, it's a slope, right? Remember, these are the same thing. So this would be 15 over 1, right? So 15 per every 1 week, $15 per every 1 week, okay? All right, and then what's the input variable represent, or our independent variable? We've learned in previous lessons that it's always the word or category that comes after per. So our input would be our number of weeks. It's our X variable, our number of weeks, input or your independent. And then our output variable or our dependent, it's always on the left side of per. So this is always on the right side of per. It's the word that comes after per here. And then our dependent or our output is our Y variable, and it's always what this one is. So it's money or total savings, right? Total savings. And how are we tracking savings? We're tracking it in money. Okay, so now we need to come up with an equation. So we already established that there's an upfront. We have a starting amount. We already have it saved, is $50. And then we're going to put our rate, which is our slope. Our rate goes next to the X. Okay, so we've been doing this for weeks. So you should have been able to write that equation. And f of X, that stands for my Y. Okay, so we could write it like this. We could say f of X, we could change that to a Y. And then I could put my rate and then my upfront. Or you can put your upfront and then your rate. So either way works. Okay, so now the 365, If I wanted to figure out how long it would take to get to 365, where would I put that? That wasn't specifically in this problem. I didn't ask you to solve the problem. All I asked you to do was write an equation. But where would we put the 365? Can you figure that out? Where would that go? Which variable would that go in? Is 365 our input? Is it our number of weeks? Or is it our output, our total savings? And it would be our output. So if we wanted to figure out that number, we would put the 365 right here, because that's how much we have to have saved if we want to buy the surround sound system. Okay, so 365 is what we'd have to get to. That would be our savings. Okay, the final thing that you need to do is you need to write yourself some type of a tip about these notes, finding slope and equations, or a question that you still have. So either write yourself a tip or a question, and we will continue working on slope and rate, but we're making progress here. Okay, so go ahead and finish up those notes, and I will see you in class. Okay, we'll see you. Bye.